Hey everybody, Harold here with the third in my Polar series. Today we're going to talk about filtering Polar's data frames, little housekeeping. For the next few tutorials, we're going to be using Pokemon data. I'll put the data file in my GitHub repository. You can access here. You need to download it and upload it to Colab each time you run the notebook. That is one of the drawbacks of Colab. It doesn't hold your files in memory because, well, basically Google doesn't want all that stuff in there all the time. So to do that, you open the File menu, click on the Upload Session Storage button, go find your file. You can download it and put it somewhere and then go find it there and upload it to here. There it is, Pokemon data. So it's uploaded Pokemon data CSV to my Colab. We can now work with that data in Colab. Uh, there's two ways you can read the data. The one, which we'll get to later, is just scanning it. That's lazy evaluation. I'm just going to touch on it real quick here. Lazy evaluation is one of the most powerful features of Polars. We'll cover it in detail in later tutorials. Basically, in the convention areas that say LF instead of DF for lazy frame, instead of reading the CSV, PL scan, I'm sorry, PL dot scan, and you can see all the different data types it takes. CSV, uh, Pokemon data, .csv. And if I say print LF, you can see what's going on here. It's not reading the file in the memory. You're not going to see the first 5 rows or 500 rows or whatever. You're going to see this. What it does, it shows you the plan. It scanned Pokemon data, gave it an ID, found out there were 12 columns. So it scanned it, knows what's in there. It's waiting for you to ask for something. It's not going to pull it into memory unless you ask for it and say collect. And we'll go over that a lot in the video on lazy evaluation. For our purposes today, we want to read eager, which means it loads uh, the whole thing right into memory. If you're working with millions and millions of rows, you always want to use scans. But since we're running with a small data set, Pokemon's not that big, we will load eager for the next few tutorials. We will load eager for the next few tutorials. I'll use DF for eager and LF for lazy when I create data frames, and I'll use result and for eager and query for lazy when I do a solution. So to read, we'll say DF equals pl.read underscore and see all the different things you could read from JSON, Excel, Indy, JSON, Parquet, etc. We just want CSV. And again, the name of the CSV, a path if you got a long path. If you have it at Colab, it's a relative path, so it's just right there. Pokemon data, that's CSV. And then I'll just print df.head, show you what we got. So a 5 by 12 df got 12 columns. You can't see them all, attack, defense, etc. because it stretches up the middle ones and shows you the first and last, but there are 12 columns. So that's look at our data real quick. Basic filtering. When you filter, the column you filter on is what it looks at. It's not going row-wise. It's going straight to that column before it does anything else. So I want to find Pokemon, fast Pokemon, speed greater than 100. So I can say result equals df.filter. What do I want to filter? pl.call speed. So it's immediately only looking at the speed column with my condition greater than 100. Then I can chain these together, select just name, speed, and let's print that. So there is fast Pokemon, Beedrill, Mega Beedrill. They got weird names, don't they? Uh, so there you go. 106 rows, 2 columns, name and speed if it was over 100. You can use multiple conditions. For instance, find Pokemon with attack greater than 90 and defense greater than 80. So I would say result equals df filter. Let's say I need to put this all in parentheses. pl.call attack greater than 90 and pl.call defense greater than 80. So and print result. So now we have, let's just select name, attack, and defense so we can see this better. So we can chain that on there. All right, and you see all my attacks are greater than 100 and all my defenses are greater than 80. Uh, we can do string filtering. I'm just showing you the basics. I'm going to get into a lot more later. But say I only want Pokemon who have a type 1 of fire. The result equals df.filter. What am I filtering? pl.po type 1. Then I have to say equals fire. Not equal, just equal. And print that result. So there's all my fire Pokemon. Charmander to Volcanion. Charizard. There's many other string methods. I'll just give you one for an example, but I can do a whole video on that. Uh, let's say we want to return all Pokemon who have Soar in their name. I know there's Bulbasaur. So result equals df.filter pl.call name. And you can do a lot of these string methods. Dot string dot. This one is contains, and then the string or substring you're searching for, and then print result. So Bulbasaur, Ivysaur, Venusaur, and Venusaur, Mega Venusaur are all the Pokemon that have Saur as a substring of their name. You could do Boolean filtering. I want to find the Pokemon who are legendary. So that's a Boolean filter, or have a speed higher than 130. So I could say result equals df dot filter pl dot call legendary. And that right there is the argument. That's saying filter it if it's legendary. That means if it has a true value in the legendary column, return it. Or it has speed greater than 130. I'll say pl.call speed greater than or equal to 130. So why don't we go ahead and dot select um, name, speed, and legendary. So we another chained on another selector. Let's print that result. So 78 Pokemon are returned that have speed greater than or equal to 130 or are legendary. So they could be both. This is legendary, but speed less than 130. This is speed greater than 130, but not legendary. So they use the or in Boolean filtering. Um, Again, a lot more ways you could filter this. Practice this on your own with Pokemon. That's it for the video on filtering. Next, we'll move to the with columns context. I hope you liked this. If you did, please like and subscribe, and I'll see you next time. Thanks, everybody.